Welcome back to this live stream of me coding a HTTP server from scratch in C. Last time that was actually yesterday, we tried to implement the construction of a response, and it actually worked just fine. Yeah. And what we also did was we tried to optimize the HTTP header map by making it fixed size and basically the size as a power of 2, such that we don't have to use the modulo in this case. Yeah. And what we also did is we adjusted the hash function to make it a little bit more efficient. Yeah. So let's start off, open a new tmux session, and see where we left off. Okay, so yesterday we actually left off in trying to construct a response for the GET requests, where we have to basically load our static files and want to serve them out. So we have some static files. Let's see. How we can just delete all. We have some static files. Some set of static files. And they are in some folder like, I don't know, static. I don't know, in some folder. And our program server. Our program now goes ahead at startup, looks at this folder, reads all its entries, and stores some mmap, some memory map file in its file cache. And we said this is at max 16 files. A problem we had was to construct, when constructing response, we also need to allocate strings. So especially when a different problem, when we want to construct a response that looks like this, HTTP 11/200 and content length (12). And hello world. I think there's another character return line feed here. Yes. Hello world. This 12 here we have to allocate. So we have the number 12, which comes from this content here. But the string, the 12 as a string, we have to allocate. And we did so by using a stack allocator, but I thought about it, and actually we don't really need the stack allocator for this, because we can just have a arena that we use for each request response scheme. So the idea is, okay, we get a request, we try to we get a request, we try to construct a response like this, and we have some memory. Let's say this is our string arena. the request comes in, we allocate, we may allocate other strings. We allocate, we allocate it to this heap here. And when the response gets written, so write the response. When the response gets written, after this flushes all of the memory we allocated here. And I think this is a lot nicer than having to keep track of the stack and the amount of frees we have to do. So actually we changed these methods back to void. And we don't need a stack allocator, but a arena allocator. Okay, so in our serve, we did this here. And basically what we can do is use this arena as our string memory. So we don't need this. Destroy the string memory. Gosh. Maybe we call it something else. So this is like maybe our request local memory, string memory. Oh. Wasn't full screen cam. Nice. Yeah, so let's show this again. These strings here in our header have to be allocated because we don't really know the size ahead of time. It could be a 12, it could be a 123, whatever. So we need some memory where we can put it. And this is our string memory. And I think request local memory. So this is the request local memory we acquire. We init it. And I think so as string memory. And this is the request local memory. Okay. So we don't need the stack allocator for this. At the moment, so let's remove that. And see if it still compiles. Okay. So there's still string memory, request local memory. Okay, so and freeze. So we don't need this. We don't need to free anything. And I think when we close the client socket, we clear both maps. And we reset the request local memory. So now in string.h, we don't use a stack allocator, but an arena allocator. And string in handle post request. We don't need these return statements. And also in handle get request, we don't need them anymore. Okay, so string okay. So the question now is, so now we are in let's for now just say that this doesn't exist. So this is more like a destroy. So munmap or returns just an okay. So this was obviously wrong. Okay, so now a file cache. We have to read the file. So we now have to have some mechanism of reading in the files. That is, just put an mmap into our array. So let's see where we have the file cache. Build the cache. I think it has to be in file, yeah, file cache, and build the cache. So this gets a dir. I wonder oh, thank you. Greetings to Zira. Welcome. Okay, so what do we want to do? So we want to build our file cache, and that's basically a map of the file name to some memory mapped file. And yeah, we copied it all over into our handle. We copied it into our handle. And obviously we now have to create an mmap to that specific file. And the problem is that we don't know the entire path. I mean, we could say that this static dir here is just hard-coded. That would make it a lot easier, but then you can't really configure it. But that may be fine. I don't quite remember how you even get this dir star. Returns a dir entry. Let's see. Oh, I think it's get dir entries, isn't it? No. So what was this again? Get dir entries. System call get dir ends. Referred to by the open file descriptor into the buffer pointed to by dir. Okay, so this is just so let's look at the man page for dir. Oh, so this is open dir. Open dir does that. But we might just use the get entries because we already know that this is gonna be a fixed size array. So what we could do is we say that we have an array of dir ends, static files, something like that, and that is max static files. And we basically read with get dance a Linux dir end. This man page is a little dir ends. No, it was get dance. Oh, so we have to make a syscall. So either we do get dir and 64, or we have to make a syscall. So because there's no wrapper. So maybe we just use that. Get then 64. So this has to be a Linux dir and 64. And the file descriptor. So build default, build static, maybe static cache, I don't know. And in our file cache we probably build static. We build a const exp, so const expr. So this is the file path, which is just slash static. Where do they store it? Is there something like a slash static slash var slash I don't know. So I don't know. A static file dir slash var slash www slash static. I don't know. Path. Yeah, I don't know. So let's just use that. We first have to open that. So open, and here we have to refer to the static file dir, and we have to open it with, I think it's just read. OO directory. To avoid denial of service problems if OpenDOR is called on a first in first out or tape device. So let's just try. Okay. So O directory or O read only. And if this is probably -1, we return -1. So get and 64 now. Why doesn't it get D ends? Yes, there is a D missing. I16 FD is equal to this, and if the fd file descriptor is less than 0 or equal to -1, then we return -1. I think this returns -1. We'd have to look at it. So return value on error -1. Okay. So get dir entries. This expects the file descriptor, our static files, and our max static files. And also we have to cast this to a void store, I guess. And this returns a pointer. The number of bytes read is returned. On end of directory, 0 is returned. On error, -1 is returned. Okay, so end files is equal to this, i16, and if end files is less, so no, this is the number of bytes read. So we probably have to the number of bytes. Oh no. This is not the number of files, but the number of bytes written into this static files thing. So that is unfortunate. Read bytes. Let's call it read bytes. Now we have to infer the length. I mean, either we do it this way or we do it actually a different way. And these can also be files, so maybe we don't even do it this way. So I think we don't do it this way. Make an open dir that is a dir star, or static dir. If the static dir is null, if this is not set, I guess. So what does it return? Returns a pointer, on error null. So if this is not set, we return -1. Open dir probably just takes, yes. Static file dir. We don't do this. Read dir. So let's just do a let's just do an infinity loop and read that. maybe we do it this way. Say, okay, so this is set, and we probably first have to check whether this is a directory or a file. So dtype. Dtype can be dtreg. So if the current handle, no, current entry dtype is not equal to dtreg, then we continue. So if this is not a regular file, we just ignore it. Otherwise, we copy this into the pointer. Maybe we should call this file name file cache. So, oh no, we don't need this. We don't need this. So we probably also don't need the struct, but regardless of that, okay. So we have a file, and now what we need is the entire path. So we have to join. We have to join the two. So let's say our car path buff, and this is the static size of the static file there plus 256. And this is the file path length. Maybe we also include inside the file cache this slash here. So let's memcopy into the path buff the static folder and with the size of the static folder -1. I probably need this here. We copy it into this. And then we have to copy the file path also into this. So memcopy path buff plus size of static folder -1. So starting at the next character from the slash, and copy into this the file path, no, the current entry dname with the size of, no, with the file path length. So this should now be our path buff that we can use to memory map the file. So the first argument is probably not, so oh no, we can't right now. We have to first call stat on the file. Is it fstat? No, stat. So we can call stat with the path buff. And it requires a struct stat file fstat file stat, and we just give it the file stat. I think that's it. And it reads into the stat. Which we now need the st size. So this is the file stat.st size, and stat also returns an int, right? No return? Oh. Fstat. On success 0 is returned, on error -1 is returned. So if this is equal to -1, we can also not do this. And file handle. Let's make this a car star. Oh, this was the one we need. Oh, this was the one we needed here. So we just erased it. The file handle and the usize file size. So protection, I think this is just prod read. We don't want to write to it. And map private, I guess. Some flags. The file descriptor, which we don't have at the moment. Is it inside the dir end maybe? No. So we probably inside the file cache need a file descriptor as well, such that we can close the file when we turn the server off. So we also need an i16 file descriptor. Open the path buff with read only, and if the file descriptor is equal to -1, we return -1. And we pass in the file descriptor and an offset of 0, I guess. So I think the last one was the offset, yes. Okay. And this can also fail. On an error, it returns map failed. So if the file handle is equal to map failed, return also -1. So we now have a file handle, we have a file descriptor, we have the file size. So we can officially construct this thing, and I think we just do it down here. So we copy the file name into this thing. And we probably need a strand copy here. Maybe. Okay. We copy it over. I think strand copy is string.h, yeah. No. So we copy it into the file name, then we set the current handle, file handle is equal to the file handle, the current handle file descriptor is equal to the file descriptor, and the current handle, let's make it a little bigger. What do we had? The file size is equal to file stat dot st size. Okay. And in the end, we probably just set our, what was it called? Result length is equal to I. No, it doesn't work. Plus result length. Okay, so this should build our static file cache. Hopefully. And in our GET request, we provided the file cache. And we also probably need to implement a GET, yes, file cache. So this is the building and the GET. So file name, should it be string equal? No, it should not be string equal. It should be mem equal pointer question now is, should it be a string? Yeah, it needs a size. So the question is, so let's just check if the file name length is greater than 250 file path length, then we return -1. So this cannot work. And we provided the length of the file name for the mem equal handle file name. So this should already be a pointer. Let's see what the compiler tells us. Okay. So we have to cast this. Do we need to cast it somewhere else? Open. Okay, so we need to include some things here. So fc ntl stat stat struct stat. Systat. Okay. Okay, so in the file cache, the destruction is also wrong. File handle and the file size. Oh no, so there are two now. So this is file handle entry maybe. File handle entry. File handle entry. Let's search for file handle entry. Content. Okay. Get request. File handle entry. So get should be defined here. But why does it try to use I think because I forgot these here. So source file cache.h. No. Make HTTP server. Cannot convert to string. So cannot convert it to string. Why are you even trying to convert it to a string? This should be a file handle cache. A file handle entry. Is there some collision here? Why? Why does it try to do this? Was not declared in the scope. Okay, because okay, I see. Because we forgot to make this. Okay. Build static cache. Build static cache. Okay. We're getting somewhere. Build static cache. And also this has to be initialized, I guess. Yeah. I mean, inside the file cache, we can probably just say, okay, results length is equal to 0, and it would work. So we don't have to call init here. So we built, maybe this already works, but I don't believe it does. So let's HTTP server, and let's break at 200, break 200, run. Oh, and it didn't work. Okay, so obviously we have to make the var www static. Okay, so now it does something. There are no files, so maybe nvim /var www static. Make a new file, index.html, html /html body /body hello world. I don't know, maybe something like this. Break build static file cache. Okay. So this is some incomplete type. I don't know what that even means. Okay, so Yeah, okay. Oh, we didn't set the current entry, did we? And file cache. Did we update the current entry? No, we didn't. Break, build static cache, run. Oh, so the continue also wrong. I think this should work. I think we can also put it there. Yes, that's possible. Current. No, not current handle, but rather current entry. So this is just the current thing. This is the parent directory. Now this is index.html. Nice. So we memcopy p path buff. So this looks correct. We have a file handle and hey, look at this. Index.html, nice. Look at the current handle. So we have the file name index.html, some file handle, file size, and a file descriptor. Hey, it works. Okay. So now in handle get request, we want to see okay. So let's see. GDB, let's see how we handle the get request. So break handle, handle get requests, run. and curl dash x get localhost 8080 index.html. So, oh shit. Request. This is also something we should not do. Request target. So in our, we just didn't initialize it. So this includes the slash. Should we include the slash in this case? So this obviously won't find anything because the slash is in there. We would have to say something like request target pointer plus plus. This is kind of hacky. Oh no. That's kind of unfortunate. Okay, so now it works. Break at get handle get request run. Ooh, so and the length. So maybe in our parser we should already do this, or we do something else and say that this is So this obviously doesn't work. Sig int. How do you gdb send sig int? Signal to. Okay. So break at handle get request. Oh no. So this is stupid. It didn't make it. Signal 2. Hello? Handle get request. p request target. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So make sure that this is actually safe. Okay. Oh, it found it. Nice. Not found. So this is the 404. Not found. So a not found 404. Not found response 404. Now our HTTP. We also have to add this. Not found. Not found response. So this becomes a not found. But in this case, the pointer becomes the file handle. This is file handle dot file handle and file handle dot file size. So now we this is file handle dot file size. So this cast probably can be a problem. This cast can become a problem. Okay. Let's just start the server, and it crashes. Shit. Oh, unfortunately it crashes. That's too bad. Please, come on. Come back. There it is. So at some point it didn't like it. Maybe it was the no. So maybe it was, let's break here at 254. Break 254. Run. Okay, so the response is a 200. There's no reason. The version we didn't set as well. So there's content length. And the value is, I don't know, some pointer. Oh, so 7 is wrong. So our content length is wrong. So let's break at break handle get request. Run. Blah blah blah. We get it. Status code okay. It should be 47. So this is obviously complete bullshit. So maybe we did something wrong here. Break at use size to stir. So print X, okay. Print the leading 0 count. This is 26. So is there some way of printing in binary? GB print hex. Okay, it was like this PXX. Or is it binary? Print binary GB T. Okay, so this is 1, 2, 3, 4, 5, 6. So the leading 0 count cannot be 26. What is the size of use size? So this is wrong. This has to be U64. And otherwise it doesn't work. So this has to be a U64 And this file size probably is not U64 to stir. Okay, it works. So break U64. No. Did we make it? Okay. Run. So next, print the leading 0 count. It's still 26. Is it because the built-in CLZ is using count with U64, U32, leading 0 count? So the question is, what is the built-in for this? CLZ. So let's get it built in. CLZ. This is an unsigned int. Unsigned long. Unsigned long. Yes, so we need an so this was wrong. This has to be long. So print the leading 0 count. This is now 58. So this is, yeah, this is correct. And decimals, this is 2. This is correct. So 77 is obviously wrong. Oh, because there's another bug in this where we have to set x to n. So now it probably should be right. Break at handle get request. Next. So print the content length value. So now it's 47. Write response. So write response fails. Break write response. Oh, of course it fails because we already closed it. So this is stupid. This is obviously stupid. Break at write response. Run it. Okay. 70. Field value, so this is correct. This works. Continue. Empty reply from server. No, why? Okay, it fails somewhere else. Maybe we can't write from that mmap to... Maybe we can't do that. Then all of this would be pointless. All of this would be pointless. Let's see. So now at this point, we probably want to break at 86. Break at 86. So this seems correct. Oh, it doesn't work. Okay, so this doesn't work. Good to know. So we have to revisit the file cache. And the file cache now needs we call it the content handle probably. But first of all, I will go ahead and make another T. So yeah, see you when I'm back. Okay. So it's the content handle. Also, what we did forget was to close the file descriptor. But first of all, I mean, does this close? Does this close the file descriptor? On the other hand, closing. So we probably have to close the file descriptor as well. So close, if close. Handle a file descriptor. So we have to rethink this. Shall we read the entire file now? Probably. So we read the entire file. So we don't probably need this here at all. Okay, let's look at when we build this, we copy this over, we get the stat. This is something we want to do, but instead of this here, what we do now is we just read from the file. We read from the file descriptor. And now we need to allocate some buffer. So we need some memory. We need some memory. Now, obviously, we have to allocate with the alloc. We have to allocate filestat.st size times the size of car, which is just 1. Okay, we allocate this. And this is now our content handle. And now we read into the content handle with the file stat.st size. And this can fail. This is the number of red bytes. So I16 red bytes. this can fail as well. So if the content handle is equal to void star -1, then it doesn't fit. If read bytes is not equal to file stat t size times size of car, return -1. Content handle okay. So obviously now we don't need this anymore. But now we have to change the interface. So this now gets an arena allocator. We have to include that. So we include them, and now in our main.cpp, this is not a request local memory anymore. So let's call this arena allocator our program memory, and let's init it. And let's do something like a file cache size. Let's say this can be 8 megabytes. This is maybe 10 megabytes. And in our arena allocator, we want a method that tries to make a sub-arena. And what we want to do is results arena length so we call it size and then length. So let's call this length I don't know, length. So this is basically the same thing, so we can copy it. Turn this, set the result. I think we call it start. Offset is equal to 0. Oh no, plus equals the length. Result offset is equal to 0. We don't return anything but 0. Do we have to set something else? Also the length. Let's call this alloc. Okay, so now in our serve method, we say we request our program memory, our memory limit, and then we have another one that is our request local. Request local memory. And this is a subarena. This is our memory limit minus the file cache. File cache size. File cache limit. And then we want another subarena that is called our file cache arena. File cache memory. File cache memory, and this is just that. And when we build the cache, we pass in the file cache memory. Let's see if this works. Okay. Some syntax error. So this is now the content handle, file state. That doesn't even make sense. File state. Read. Uni standard. Content handle. So we have to cast it to a void star. I mean, the file descriptor, we don't really need this because we can close it off. I mean, we could also leave some empty if this is not possible here. we could leave some entries empty if they don't fit and put them back into the cache when they were used. LRU. To do, consider making this a hash map. Okay. What are you trying to tell me? There is a content handle. Oh my goodness, there's an equal sign missing. Okay, so the destroy method shouldn't really do anything. So there shouldn't be a destroy. Just deallocate the memory. And we destroy the entire memory, which is our program memory. Okay, so still there is a file descriptor. Okay, so I don't believe that this works. Break at build static cache. Okay. Index HTML. (47) read I mean, ultimately this has just become a string. Okay. So now let's say break at handle get request. File handle. Oh. So this is nice. (47) with 2. Shoot. Doesn't want to. We also this is kind of odd. Break write response. Continue. So this looks correct. Length 47. Ooh. Why is it refusing to do that? Oh my goodness. It probably worked. It probably worked before. This is stupid. This is quite stupid. Okay, so, but it should find it. What was it, 84? Break 84. Oh man. Now it's dead again. Nice. The server is dead again. Shit. So our closing mechanism is somehow broken. So it should send of. It shouldn't be 0. Access found. Why is there a 0? So it somehow did the wrong thing. Why did it roll? Did we insert another header? I don't think so. There shouldn't be 0 in it. there shouldn't be a 0. Why is there content length 0? And okay, 70 bytes. Oh my god. This is stupid. Why is there 2 times a character return? I think there should only be 1. So this was obviously a mistake from my side. We want to look up the status line, and we also put it CRLF, so this is also wrong. Then we put a CRLF, and probably we're then fine. Hey! There we go. Look at this. And if we go localhost 8080, nice. We can now officially serve static web pages. So this is nice. Look at this. Okay, nice. So git status, git add, git commit, added response construction, as well as static file caching. Okay. So this is actually nice. So we can now have post requests, we can now have get requests. And if, for instance, we add another file like test.html and let's say HTML body test, this is the test site. When we now start the server and we curl test site, so localhost 8080 index, Okay, there seems to be... Okay, we have a bug. Nice. We have a bug in our file cache. We forgot to increment current handle, and so it just got overwritten. Oh, nuts. Again. So test. So now both don't return anything. Oh no, because we can't increment the current handle. We can only increment it here. Oh my goodness. So closing is kind of still wrong. Fix the server closing. Okay, so yeah, now it works. Look at this. Look at this. That's something. Okay. So git status, git commit, fix, file cache, overwrites past static files. Okay. So this works. This probably would have worked with the file cache itself, with the mmap as well. But that's all right. 1 second. Okay, sorry. Have to answer something. Okay. So should we do some error handling? Should we maybe fix the closing of the server? Also, what we have to do is implement we have to implement transfer coding. Implement some transfer encoding. For the response maybe. But this might not actually be worth it. What we could also do is make it multi-threaded. Make the server multi-threaded. So multi-threaded server. That might be something. Also, this I don't really like. Maybe. Yeah, but the signal handler. The signal handler is something I don't really understand. So if this here returns a -1, and we also did close, so I think the problem, let's look at the error handling, because I think the problem is also this here, the initialization, probably something we don't want to do here. Probably something we want up here. Okay. So at the moment there's no parallel. So we have one connection. We can only handle one connection at a time, which is not very nice. But also, first of all, we might just consider doing this here. So the closing is somehow broken. And I think it's because we closed them over. We try to close them here, and then we're still trying to read from it, which will inevitably result in an error. I mean, if we do the sig int here, this should close it. I don't know why it doesn't work, though. So when we go to close client socket, we close the client socket. So I don't know why this is not possible. Why this is not. So if we had a connection, let's say this, and then we curl, then we close this, it doesn't work anymore. So if we had a connection, so is it maybe this except here? That causes the problem? I mean, we can look at it. So let's call HTTP server, let's make a connection, let's kill this one, and now it doesn't work. So break serve, run. Okay, so binding doesn't work. Do we have to unbind? Bind assigns. So obviously it was not closed. We need some way of killing the server. I wonder how they do it. So Do they do it? Do they have a signal handler? Like something close. Close the sock. No. Oh. So I wonder what's going on here when we. Maybe it has been closed. So we had a connection, and that connection probably got closed. It may have been closed by another party. So we probably have to read the error now in this case. So if they just left it, but I don't think this is the issue. So read can be less than or equal to 0. And if it's, yeah. So in this case, we probably also have to okay, so read if count is greater than blah 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 blah. Error is set to indicate the error. In this case, it is left unspecified whether the file position, if any, changes. So I wonder what a good sorry. I wonder how we can handle this correctly. So the question is, what does fail? When we're trying to read, and read is going to cause this to close. Read is going to cause this to close, obviously. And even accept, because we destroyed this one. And then we're trying to close it again. But I don't see why. So 98 was the error. No, 98. Address already in use. So have to wait. Yes, this is intended. Okay, this is intended. Wait, there's a time wait state following. Out in the network on their way to you. Treat as a valid packet. It's generally set to double the packet's maximum age. So a better solution is to vary the port numbers used for the originating end of your sockets. Once you do this, you won't really care about wait time for individual sockets. Okay, so I think we just use SR reuse when we bind. Is it bind or is it? I think it's. So how do I set the socket options? Set socket opt. Set sock opt. So set sock opt. So the level to indicate that an option is interpreted by the TCP, set the level to IP proto TCP. Okay. So the socket, which is the socket descriptor. How do I call it? Socket descriptor. Then the level. The level, which is IP proto TCP. Then they want some option name. Socket option. Reuse EDA. Then they want the option value. If option name is equal to S blah 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 blah. Point to by option value. How do we get the option value? Option value. Probably this is specified here. I don't like where this is going. To the value point to by option value argument for the socket associated with the file descriptor specified by the socket argument. I don't really like this. is this get sock opt? To manipulate options by at any other level the program of the protocol. For example, to indicate that an option should be set to a number of TCP. I think we. Oh no. Okay. Okay, so this is probably just a 1. So opval strong. This is size of opval. I wonder if this works. If this is equal to -1, go to. Okay, then we may do that. Shit. Now 22. Invalid argument. Great. Op value may be null. Is it just null? Oh no. Utilize an int argument for opval. The argument should be non-zero to enable a Boolean option, or 0 if the option is to be disabled. C sockets. When the listening socket is bound to inArray, argument is an integer Boolean flag. So this probably was right. But maybe this is wrong here. So reuse header. Okay, so get proto and get proto by name. Maybe it's just get proto by name. Get proto by name TCP and this returns okay. Proto and TCP proto get proto and get proto by name TCP. What does it return? Get etc protocols TCP. So TCP is it uppercase or lowercase? I don't know. So maybe it's lowercase. TCP proto. Okay, so in here we say this is what does it return? Return a pointer to a statically allocated proto-end structure, or a null pointer. Okay, so this is a pointer. If not TCP proto, return -1. And set sock opt TCP proto dot no, and then p proto. But I don't even know if this is the problem. netdb.h netdb. Okay, it's still wrong. So the level To manipulate options at sockets API level is specified as SOL socket. So this is probably SOL socket. No. Okay. So this is probably has to do nothing with TCP. Reuse. Hello? No, it's not the size of it. Oh, I16. Probably this was a problem. No. Okay. What was it called again? See also socket man. SO reuse adder. Oh my god. So, this is nice. Great. Can you even close this? Great side. So this was something I wanted to look at. Oh, this is so annoying. So invalid argument. I don't know why this is an invalid argument. Op name, op val, socket length. Invalid argument. My goodness, please. I mean, I don't really know why this actually doesn't work. So this should be set on a socket level. Is it maybe because we didn't bind yet? Do we have to bind first? Maybe we can look at some GitHub set sock opt. This is ridiculous. HTTP server C GitHub. I mean, somewhere they have to set it. Or don't they do it? Set sock. So they don't do it. So they don't use that. Why is it invalid? Is it because it's a 1? What if we do 0? Still. I mean, I thought this... I mean, also when using TCP, it doesn't work. Socklen. Initially containing the size of the buffer pointed to by opval. The actual size of the value returned. What? So what is a socklen? T. This is an integer type of at least 32 bits. It has to be 32 bits. Okay. Fine. And it doesn't even matter. Okay, because I think we set it to 0. No, it doesn't matter. Please. please. Okay, now it works. Okay. So if test and if count define test true. Hello world. Test. Index. Okay. And we close it and reopen it. So nice. Probably let's call this debug mode. Test. Debug mode. And we can also make this a pass arguments from make to C preprocessor. So this works. C flags. And be sure to use C flags in your compile command in the make file. What? So what if we don't do this and instead say make debug mode 1. So they don't get passed down. Extra flags to give to the C compiler. C flags. Okay, so maybe we want to do it like this. When we call -c, $C flags. So maybe make check if option variable is defined. Conditional syntax. If define, so pound if defined, if def debug mode. What would this look like? Then we do this, and with the debug mode is equal to 1. Debug mode. The debug mode. GCC with GCC dash D debug mode is equal to 1. I wonder if there's kind of a way that we can make this a macro. And I suppose this doesn't even work. Else gcc dash g dash c source file cache dot cpp, and if define debug mode else gcc source allocator dot cpp, and if def debug mode else c-c source stack allocator dot cpp, and if def debug mode else gcc-c source http header map if def debug mode else gcc-c source http.cpp and if define debug mode else gcc-c source main.cpp and if. Okay, so if we call now make with debug mode, make HTTP server debug mode, make clean debug mode okay. So this works. When we call now the HTTP server, we curl it. Okay. Localhost index. And if we say make clean, make, then we say HTTP server. Okay. So that does work. So make clean, make debug mode 1. Okay. Okay, I have to pee and be right back. Okay. So let's get back. So this now works. If we're in debug mode, we do this. What is 2 to the 16? Okay. So that was also a problem with the port. Okay. So now what we want probably is handling post requests. And probably we want some functions that handle certain post requests, but for now we just want to register emails. So let's try to do this. When we have a post request, so string to U32 is something we haven't implemented yet. Fast string to U64. Yeah, maybe we just implement this here in our string library. Stir to U64. Okay, in our string CPP, I want to implement this. We don't need an allocator in this case. We need a string. And at best, we start at the let's say results. Results. Or maybe U64 res. Let's say start results equal to res. We start. We have some factor. It's equal to 1. We start at the very back of the string, which is the end pointer equal to the string pointer plus the string length minus 1. And end pointer is greater than or equal to the start pointer minus end pointer. If this is a digit, so let's say UA digit is equal to star and or current car star current car, and it is minus the 0, the ASCII representation of the 0, and if the digit is less than 0 or the digit is greater than 9, then we have to return -1, so the string is not a valid number. Otherwise, we can say res plus equals the factor and the factor times equals 10. Plus equals the factor times the digit. Okay. Stir to U64. Content length. If this is greater, we just have the bad request. Yeah, and here we have an email. So let's say okay. If this is equal to -1, oh no. Well, we have to also construct a bad request. And U64 content length and this is not the message body, but rather no, this is the string. Int content length int content length. cannot convert from string star to string. Okay. GDB HTTP server. And break at handle post request. Run. And let's say we post to, let's say we post to this with the data test at google.com. Okay. Content. Content length int 15, that is correct. And P, the message body. Okay, so this is already the email. So we would have probably something like an email validator. And we of course need a database as well. Yeah. So the idea is, yeah. So that basically should be it for now. A lot of duplication here. Maybe construct bad request, I don't know. Oh, I think we have to respond with a HTTP, we can do that. So void init empty response HTTP response and status HTTP status code. We say result status code is equal to status code, result reason is equal to null, and results message body is equal to 0. So init empty response result with bad request. With not implemented. I mean, we don't. Init empty response. Could also do this here. Okay, and we also add something to this. The caller has to ensure that the header map of the result was initialized. And init empty response bad request. So same thing here. So, but this is not an empty one. Init empty response result and not found. Make HTTP server debug mode 1. Okay. Oh. Oh, it's post. This is a 400. Because we sent no data. Four. Nice. So this works. So we could make this a little different. We could say if a man curl gzip compress automatic decompression of compressed files. No. Okay, so what do we do now? Should we start with the multi-threading? Should we start with the multi-threading? For this we would need, so the idea is, let's first write down the idea. The idea for the multi-threading is the following. So we will have multiple threads here. We will have multiple threads. That are capable of parsing HTTP requests and sending out the responses. So in the end we have one thread here, T0, and this thread is listening to incoming connections. This is listening to incoming connections from outside the world, from the world. And in here, what it will do is we will have a queue, and we put these connections onto this queue here. And these threads here, they will watch this queue. Obviously, we need some synchronization here. They will watch this queue for these client file descriptors, and they will take one. So thread 1 maybe take this one, thread 2 takes this, thread 3 takes this, and thread 4 does not take any. And now they have this client and they read from the client. So they now read from the client and send responses back. And when they're done, they close the client file descriptor and put it back onto, and continue reading. Well, so this is just multi-threading. And this is what we will implement in the first place. But we could also implement concurrency, where on an individual thread we can have multiple of the connections, and we read when there is something on there. But this might not even be that interesting, because yeah. So we will first try to implement this here. And for implementing the multi-threading, we need this queue here. Which needs some way of synchronizing. And we need a mutex for this, probably, and some signals. So the problem is, in these threads, we could say, just look at this queue all the time in a loop, but this will spin a lot, and yeah, this will cause our CPU to have a utilization of 100% all the time, and this is something we don't want. So we can say, look at this queue, and if there's nothing in there, go to sleep. Add yourself to some watch list, and when the thread here acquires the mutex and puts something on here, we signal this thread that something is on there. So for this we need signals. Okay. So for this we obviously need some signals, and maybe we just start by starting to implement the queue, worker queue. Let's call this the worker queue. And before we start this, I will go make me a tea. And let's just finish this. So let's, yeah, I will grab a tea, come back, and then we will do this. Okay. So we're trying to implement a worker queue now that basically can take client that stores client file descriptors such that we can handle the connections on the individual threads in a way such that we don't have any race conditions. And we're gonna use a mutex for that. Wait a second. Okay, so we introduce a struct worker queue, and this struct has, maybe we also introduce a constant that is max pending connections, and we say this is 128. I think we already have a similar constant in the main, so we can merge them. Because I think what Linux does in the background is something that's quite similar to this. So maybe we don't even need to do this. Maybe there's no need to do this. I mean, when we can call except from multiple threads, then there would be no need to do that, right? If this is thread safe, okay, so except blocks the caller. Is it thread safe, though? Except thread safe Linux. Okay, so we actually don't need this queue. We can just call except from the different threads. So that's even easier. So we don't need the worker queue. I mean, we can keep it in there. So handle requests, and this probably has to be a void star and take args that it. And let's just try to I mean, here we have to spawn the threads. And this is basically what's happening on the thread. Also, each individual thread needs some local memory. Is this still inside the for loop? Oh, yeah. Okay, it is. Okay. So let's call this worker args. I don't know, handle request args. We probably need a file cache. We need a, I think it's an i32, right? The socket descriptor. Yep. Handle request. So the socket descriptor. We need some memory. Request local memory. So handle request args star args. Let's just call them worker args, and we cast them to handle request arg star handle request args. What we do is we say the file cache is equal to handle request args file cache. Just destruct all of this to have it easier. So this is request local memory. And also the i32 socket descriptor. And for wind down, we obviously have to do something. So when we shut down the server, there's obviously a problem. Okay. So the serve method gets a lot easier, I think. We have to define the number of threads. U8 n threads. Let's say this is just 8, or maybe, I don't know, 6 or 8, I don't know. Let's say thread local memory limit minus the file cache limit over n threads. Okay. Okay. We probably we have a lot of the so first of all, we have some threads. Pre-thread T, this is our thread handles. And threads. We have some local memory. Thread local memory. So we have to do this for int I is equal to 0, I is less than n threads, plus I. You have to initialize a new subarena. Okay, enough nuts. So we say this is the request local memory plus I and pthread spawn, I guess it is, or is it pthread create? Okay, it's pthread create. So this is the thread handles plus I. And some attributes, I don't think we need them. Okay, then the args. The args, no, the routine and the args. Okay, I'll close the wrong one. So pthread create. This gets the handle requests and also the args. So handle request args worker args and threads. And say current args handle request args star is equal to worker args. Okay, let's do it for all of them. So pthread t current thread handles current thread handle and the arena allocator current alloc request local memory. Okay. So this is the current alloc, also plus plus current thread handle plus plus current alloc plus plus current args. Okay. So current arg the file cache is equal to the file cache. Then the socket descriptor is equal to the socket descriptor and the how did I call the request local memory to current alloc. Pthread create current thread handle and void star current arg, and I think it doesn't need the size of the arg as well. So we create this, and this can probably fail. Return returns an error number. On error it returns an error number and the contents of star. So if this thing is not equal to 0, return -1. We create them, and we probably want to kill them in some way or another. So they're probably so we to do introduce some way of winding down the threads. Okay, we spawn them, and that should be it, I guess. Why did we spawn our threads here? It should be spawned here. Okay. So we spawn the threads. And they should do some work. I mean, this should already compile. Okay, crosses initialization. So obviously this now doesn't work. Well, it should. For now, let's do this. Okay, reset. So in handle request, the request local memory, this is now, so request response, this is something we had here, and this should now be here. Okay. Pthread create. So we probably have to So pthread create, pthread create. We have to probably include it somewhere. Is it just pthread.h? Yes, it is. Pthread close server socket, close server. So if this thing is -1, I think we just continue. Well, one way of telling it would be to check whether this so is there a way to send a signal to a thread? Send signal to thread. Possibly in just one thread. Signal. No, I don't believe this works. So how do we signal this thread that it should close its connections? Does it even need to close it? So this obviously now doesn't exist. We just closed this one. So when we receive a SIGINT, we probably need this as a global variable here, the thread handles. But we also, in this case, I mean, this, again, the gesture control, ridiculous. Oh, this camera, always following me. I hate it. How do we do this? So we have the thread spinning, and what do we need the threads actually to do? Do we need them to do something? Or can they just die? So can we just close the threads is the question. So I think we have to pull this one out. Make it a global variable. And we have to initialize this to 0. maybe we just say it's null. So we kill these, and we say for int I is equal to 0, I is less than n threads plus plus I. And then if, so let's say pthread t star current thread handle is equal to thread handles. If th, then pthread kill pthread kill the thread handle and 0. Okay. Yeah, this can also, so when we allocated something, we have to unmap also. So this is the case when we have to close it. I think we have to rethink all of this. We probably even have to pull we could also have a signal, and when this fires here, we send that signal and we kill it all. That might be something we want to do. I don't like this. I don't really like this. So let's close server socket. I mean, this would kill the threads, most certainly. Client socket descriptor. Pthread kill. Can we just set this one to null? I mean, this is a pointer. Got some error. So let's walk through this. Break it, serve. Run. Next, 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 next. Okay, so I see why this is so. I may not, so we may not use this goto anymore. We can use a function call. Close server. And it gets a socket descriptor. maybe introduce a signal here from I mean, at this point, there are already threads. i32 socket descriptor and an arena allocator. Close. Destroy the alloc. Okay. So we can close the server. We can close the server. Blah, 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 blah. And at this point, we want some way of signaling that things went wrong. Okay, I think although this is a bad place to leave it like this because it doesn't even compile, I have to go. I wish you all a nice day, nice Christmas. Yeah, we will be online tomorrow, I guess, and continue with this. So, see you then.